Hello YouTube! Welcome to Coding with Dom. I'm Dom, and this is me coding. It's live. We're live from Amsterdam. It's a weird feeling. If you're here in the chat, let me know. Let me know if you can hear me right now, because I'm not sure I've set up everything correctly. It's a weird feeling to be live on the interwebs. But here we are, Coding with Dom, and today we will be looking at Godot. Someone pointed out in the comments that it's probably Godot, but then I went on a YouTube search and I started trying to figure out how people pronounce it, and there's all kinds of debates. So I'm going to say Godot just to keep people happy in the chats, but I still kind of feel like, it was based after a play with a French name. It doesn't matter. What we're going to be doing is your first game. I'm going to try and take my teacher hat off and not be the teacher, because I have nothing to teach when it comes to game development. This is a totally new thing to me, so we're gonna try it out together. I see that the video is streaming, so I hope people can hear me. If there is someone looking at me, I'm not even sure if there's anyone actually watching, but if you are, let me know if you can hear me in the chat, because I really hope that I haven't been talking for 5 minutes without anyone hearing me. Without further ado, let's go through the tutorial. So this project is an introduction to the Godot engine. It's going to be so hard to say. The Godot engine. It assumes that you have. Oh, sorry. You see, this is the kind of stuff that I'm able to cut out when I do editing, but this is live, so I can't do that. But I forgot to do the shtick. If you enjoyed this video, leave a like, subscribe, ring the bell, share with your grandma. Let everyone know how awesome Coding with Dom is and how much fun you have watching his videos. Insert blinking sound effect here. Okay, so let's go back to the tutorial. The project is an introduction to Godot engine. It assumes that you have some programming experience already. I do. If you're new to programming entirely, you should start here. So maybe you want to check out this scripting thing. Oh, just if you want to follow along, let me see if I can do this. It's docs.go.engine.org, and then once you get there, there's step by step and your first game right here on the left, just in case you're watching at home and you want to follow along, and we can do this thing together. So we're going to be building this game. The game is called Dodge the Creeps. Your character must move and avoid the enemies for as long as possible. Here is a preview of the final result. Why 2D? 3D games are much more complex than 2D ones. I totally agree. I'm very scared of 3D games. So I wanted to start off by making this. So project setup, we're going to download these assets somewhere and take these files to your project folder. For this tutorial, we assume you are familiar with the editor. More or less. If you haven't read Scenes and Nodes, do so now for an explanation of setting up a project and using the editor. I'm lazy. I'm not going to do that. I just want to build my game. So that's what I'm going to do. And this game uses... So let's open up Godot, which is, I guess, the first requirement for me to actually start building something. Yes, please do. I am going to create a new project. What was it called? Dodge the Creeps. Project path is going to be in Git. Godot. Dodge the Creeps. I'm going to be uploading this to GitHub once I'm finished with the tutorial, so you can send me issues, pull requests, you can tell me how badly I code and all this kind of stuff. Oh fuck, I didn't. Yeah, there you go. Godot, Dodge the Creeps, select, create and edit. Here we are. Do I need to move around? I guess not. You can kind of see me. Yeah, this will do. So, 2D scene, here we are. Let's go back to the tutorial. We're using click on project, project settings, display window, project settings, display, where's display, window, and it is 480 by 720. 480 720. Close. Here we have our viewport. Very nice. Very nice. Let me just extract downloads. That's not how computers work. Find the app. Here we have our downloads. Let me extract this. And I guess I'm just going to copy this as is into Godot with DOM, git, Godot, dodge the creeps, boom, dodge assets. I wonder whether they are, here they are, and they appear over here. Very nice. So we can get going. Organizing a project, we will make 3 independent scenes, player mob, what's mob? And HUD. So HUD, I can't remember what that means, but it's like the overlay, like the score and this kind of stuff. I can't remember what a HUD actually means. If you know, let me know in the chat. Interact with the live stream. Let me know things, because I don't know things, and I'm sure you guys that are watching know things more than I do. So if you know what HUD means, let me know down below in the chat. Which we're complying. It feels weird. Let me just take a moment to say it feels weird. I see that there are 3 people watching right now. And hello, thanks for joining. This is a live stream. I've never done this before, so I'm a bit nervous, if I have to be honest. But yeah, okay, let me do the tutorial. Let's not get emotional. We will combine into the game's main scene in a larger project. It might be useful to make project, blah, 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 blah. Let me just, first scene, okay, create. Is this, do I already have this? I don't know. Add, create, and add an area 2D node. Area 2D. Yes. But this should be, why do I already have no 2D? Okay, delete that. Delete that, yes. Okay, maybe I clicked on this by mistake. I'm just going to go area 2D. And then area 2D, we can detect objects and I can change its name to player. Player. Okay, now this is the scene's root node. We can add additional nodes to the player to add functionality. Before we add any children to the player node, we want to make sure that we don't accidentally move or resize them by clicking on them. Select the node and click the icon to the right of the lock. Yes, indeed. Restores the, yep, makes sense. Save the scene, click scene, save, or press Command S. Okay, player dot, I think that's how we want to call it, correct? Yes, save. Hi, Finn Bartlett, welcome. Hello. Hey, Lorenzo Shiga. Hey, I know you. Can you guys hear me? Oh, it feels good to have some interaction. So click on the player node and add an animated sprite node as a child. So animated, so it's going to be animation. So cool. Let me zoom in a little bit so that you guys at home can actually see this. How do I, is there a way to hide the sidebar? I guess I'll just zoom in more. Yes. Okay. Change its name to player. Click the scene, save. Yep, done this. We'll use the following Godot naming conventions. Classes use Pascal case, variables and functions use snake case, and constants use. Okay, not a fan of snake case, if I have to be honest. But okay. Click on the player node, add an animated sprite. I've done that. We'll handle the appearance and animations for our player. Notice there is a warning symbol next to the node. An animated sprite requires a Sprite Frames resource, which is a list of the animations it can display. To create one, find the frames property in the inspector and click empty. Okay, frames, there we go. And next, and then click empty new Sprite Frames. There you go. And then in the same location, click Sprite Frames, then click Open Editor. Is this it? In the same location, click Sprite Frames and click Open Editor to open the Sprite Frames panel. Have I already done that? It looks the same, so I think it did it automatically when I clicked on this. Yeah. Okay. By the way, if you're looking in the chat and you like taking notes, oh, hi, Marcozzini. Hi, welcome. If you like taking notes, I think this is probably something that needs to be updated in their documentation because it doesn't, I feel like I did something different. I'll try rewatching this and see if I have any pull requests or documentation improvements to send their way. But if you like taking notes and you want to take notes and send them my way afterwards, that would be awesome. I don't know why I'm delegating already work to you guys that are watching. You should just be enjoying this. But, yeah, I guess that's how my mind works. Next, in the same location, click blah, blah, blah. So we have the thing. On the left is a list of animations. Click the default one and rename it to Right. Okay, let's click this. Right. I'm going through the tutorial for those that are just joining. I'm just speeding through the tutorial, but if you have any questions, please stop me. Let me know in the chat. If you want to follow it on and you're struggling understanding what's going on, it's pointless me doing this if you don't understand what's going on. So please let me know if that's the case. If you're wondering what's going on and you have no idea what we're doing, we're basically building a game with the Godot engine. You can find a link to this on the interwebs. Just download it, and then we're doing this guide, docs.go.engine. You'll find a section on the left of the website called Step by Step, and inside there, there's a thing called Your First Game. Just in case you're joining. I already explained this at the beginning, but I kind of feel bad for people that are just joining. Anyway, let's stop. This is all over the place. I'm not good with this live streaming thing. I need editing. Okay, on the left is list, blah, blah, blah. Click the add button to create a second animation named up. So, add up. There you go. Drag the two images for each animation named player gray up and player gray walk into the side of the panel. So, we have art. Ooh. Okay. Player gray up, 1, 2. Okay, okay. I'm starting to follow up. Up. Right has walk and walk. Nice. Okay, the eye moves around. I get it. That's smart. So, incidentally, the player images are a bit too large for the game window, so we need to scale them down. Click. How do we know this? Have we already added stuff? Oh, there it is. Okay, yeah, I hadn't noticed. Cool. All right. Okay. So back to where we were. The player images are a bit too large for this game window, so we need to scale them down. Click on the animated sprite node and set the scale property to 0.5, 0.5, Where do I see this? Under transform. Scale. Nope. Okay. You can find it in there. Yep. Finally, add a collision shape 2D as a child of player. Yes, I already done this in my other video as well. Collision shape 2D. This will determine the player's hitbox or the bounds of its collision area. For this character, a capsule shaped 2D node gives the best shape. So capsule shape 2D gives the best fit. So next to shape, yes, using the two size handles, resize the shape. So if you're wondering, I'm using the pinch thing on Mac. I'm not sure how you do this on Windows, but with the pinch thing I can actually resize this. Damn you. So let's do something like this, and I guess, yeah, that kind of feels right. Okay, yeah. When you're finished, your player scene should look like this, exactly the same, like a boss, man, like a boss. So moving the player, Now we need to add some functionality that we can't get from a built-in node. So we'll add a script. Click the player node and click the add script button. So yes, yes. I guess it's going to be GD script. You can leave the default settings alone. Just click create. Indeed. And here we are in a world that feels a lot more familiar, which is a code editor. Start by declaring the member variables this object will need. So let me just copy this stuff. Boom. Okay. Using the export keyword on the first variable speed allows us to set its value in the inspector. This can be handy for values that you want to be able to adjust, just like a node's built-in properties. Click on the player node and you'll see the property now appears in the script variables section of the inspector. Remember, if you change the value here, it will be overridden. It will override the value in the script. So this is really cool in my opinion. If you see her speed equals 400, but if I go back to the inspector view, I should have somewhere, is it because I didn't save it? So Command S to save. Let me go back to this. I was expecting to, okay. Here we are, speed, 400. So if I save this to 200, save, and I go back to the script, I was expecting this to be 200, actually. That's odd. I think that isn't the desired behavior. Maybe do I, oh, okay. I'm not sure how this works, but when I click this, it resets. So this might be another thing we have to take notes about. Go ahead, you'll see the property. If you change the value here, it will override the value written in the script, but it doesn't mean it will actually change the script. Okay, that makes sense. Then we're going to do this, function ready, to grab the screen size of the viewport and save it into our variable. Now we can use the process function to define what the player will do. Process is called every frame, so we'll use it to update elements of our game, which we expect will change often. For the player, we need to do the following. Check for input, move in the given direction, play the appropriate animation. Makes sense. First, we need to check for input. Is the player pressing a key? For this game, we have 4 direction inputs to check. Input actions are defined in the project settings under input map. Here you can define custom events and assign different keys, mouse events, or other inputs to them. For this demo, we'll use the default events that are assigned to the arrow keys on the keyboard. So if I understood this correctly, this input actions are defined under project settings might be a way to map like joysticks and maybe WASD act the same way as arrow keys or stuff like that. I'm not too sure, but I'm not going to worry about that right now. So you can detect whether a key is pressed using, so yes, we already tried this. Let's just grab this and copy paste it, which is what I know how to do best. So we have velocity, which is a vector, the player's movement. If we're pressing right, then we want it to go right, so that means the x-axis will be a +1, otherwise it's a -1. If we want it to go left, the same goes for down and up. Once we've calculated the velocity length is more than 0, then we normalize it. I'm not sure what that means, but I'm not sure I really have to care. Okay, it's all explained here. Of course, it's all explained. We start by setting in the velocity to 0, 0. By default, the player should not be moving. Then we check each input and add subtract from the velocity to obtain a total direction. For example, if you hold right and down at the same time, the resulting velocity vector will be 1, 1. And in this case, since we're adding a horizontal and a vertical movement, the player will move faster than if it just moved horizontally. Aha! So that's how we that's why we use the normalize function to prevent that. Okay, so the whole idea is if I press right, I'm going to be moving like 1 block at a time right. If I press down, I'm going to be moving 1 block at a time down. But if I press both together, then I would be moving 2 blocks at a time, because like I'd be moving 1 right and 1 down, and that would mean my speed would be higher. But what I'd have to calculate is some weird math function with, I don't know, the Pythagorean theorem. I don't know what's involved to normalize it, but this normalize function automatically makes sure that it uses the right thing and that I don't have to worry about math that I don't know. Cool. So we make sure that the length of the vector, that's what it is. So if I have one sideways, one down, the diagonal of that, I should be doing it this way, not this way. So one this way, one this way. The diagonal would be like 1 point something of this 1 by 1 square. We want to make sure that the vector always has a length of 1. And we do that by multiplying, by doing vector dot normalize. Very simple. Usage, very hard to understand if you're not used to this stuff. I'm not, so it took me a second. Anyway, if you've never used vector math before or need a refresher, you can see an explanation of vector usage in Godot at Vector Math. If you're not lazy like I am, I do suggest you go read that. I'm lazy, I'm not going to do that. We also check whether the player is moving, so we can start or stop the animated sprite animation. Of course, this reminds me of jQuery, returns the node at the relative path from the current node, or returns null if the node is not found. Since animated sprite is a child of the current node, we can use animated sprite. Aha! Interesting. So by doing this, we are referring to this guy who is a child of this, and this is player. I like learning something new by the second. Okay, so blah blah blah. This is a shorthand for get node, so in the code above, this is the same as this. Cool. Now that we have a movement direction, we can update the player's position and use clamp to prevent it from leaving the screen by adding the following to the bottom of the process function. Okay, so position, uh-oh, what is it complaining about? Is it weird indentation? What am I getting wrong? Do I need to close the if somehow? No. Does it not like the new line? I don't understand what's going wrong. Unindent does not match any outer indentation level. What does that mean? This. I knew it couldn't be all easy. I knew it was too easy up until now. Does anyone know what this means? Help! Help! Okay, let me think. So the chat is lagging, by the way, so I don't know whether you realize this while you're watching, but I speak and things happen on the screen like a minute or a minute and a half later. So if you do know how to fix this, I'm gonna find out in like a minute and a half or something. What could it be? If I do this, does it complain? It takes a while to update. Identify a position. Why does it not? Oh, is it because? Oh, that's very weird. That is extremely weird. Why does it do that though? Okay, this is something that needs to be figured out. I'm probably gonna ask people about this after the video, but it uses spaces for indentation. So when I use a tab, it complains. But usually code editors know how to work around that, and if you press tab and it's using spaces, it automatically inserts spaces. It doesn't seem to be doing that for me, so I don't know whether it's a bug or whether it's intended, but I guess the fix is to manually add spaces in. Okay, well, click play scene and confirm that you can move. Are we already there? Are we already good? play. No main scene has been defined. We haven't defined a main scene yet, right? Okay, I'm just gonna, where were we? Randomize, we're more or less, no, normalize. So we were more or less here, it just says press. Actually, maybe I need to do, is this play scene? Or is there a different thing for play scene? F6. Play scene, not play game. How do I do play scene? Oh, this? Play scene. Thank you from the chat, Mr. Bartlett. I appreciate the input. So I was doing play game and not play scene. Okay, play scene. Nice. Can I? Oh, yes. I can move the guy around. Nice. It works. You see, this is already amazing for me. That with these few lines of codes, I'm already doing stuff. This is so cool. Okay. I see that the animation isn't changing depending on which way I move. I guess that's probably the next step. But cool, this works. So, choosing animations. There you go. See? I knew it. Now that the player can move, we need to change which animation the animated sprite is playing based on direction. We have a right animation, which should be flipped horizontally. Oh, fancy. And which should be flipped vertically. Nice. Okay. So, at the end of our process, we are going to do... Again, this is going to complain about indentation. Seriously. Why? I don't understand this. Finn, you seem to know what you're talking about. You have any idea why this indentation thing is happening? Anyway, never mind. Flip v false, flip page, blah blah blah. See the note below about Boolean assignment. What is the note below about this Boolean assignment? The code above a common shorthand for... Yeah, why do I need to do flip v false but I don't do flip h false here? I'm not sure. I'm actually going to add that because it makes more sense to me. So, let's try that out. Haha, this is so cool. That was so easy. Look at the eye go around. I can't believe how easy this thing is. I am amazed, literally amazed. This is so cool. Okay, I have to really hold back because I could play with this thing for hours just moving around. Check that the animations are correct in each direction. When you're sure the movement is working, add this line to ready so the player will be hidden when... Oh, fancy. I am sure it works. So now I guess if I play scene... Oh, really? Really? Why is this indentation thing keep happening to me? Okay, let me restart the scene. Now I'm not sure whether I'm actually moving when I press the keys, but I can't see the player anymore, so I guess it's right. Preparing for collisions. We want player to detect when it's hit by an enemy, but we haven't made any enemies yet. That's okay because we're going to use Godot's signal functionality to make it work. Okay. So I guess signals are kind of like events or something. let's do signal hits. This defines a custom signal called hit that we will have our player emit when it collides with an enemy. Okay. We'll use an area 2D to detect the collision. Select the player node. Where do I find this? Node. Okay. And click the Node tab next to the Inspector tab to see the list of signals. Do I have to save this? Oh, maybe I have to select this. No. Script. Let me reread. I'm going too fast. This defines blah 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 blah. We will use area 2D to detect the collect. Okay. Select the player node. That's what I'm doing here, right? Okay. I must have done something wrong. So body entered. Yes. And it is there as well. What? I'm not understanding. Signals hit. Oh, our custom hit thing. Okay, yeah, that's there as well. Since our enemies are going to be rigid body 2D nodes, we want the body entered object body signal. This will be emitted when a body contacts the player. Click connect, and then connect again on the connecting signal window. Connect. Do I just click connect again? Is that it? We don't need to change any of these settings. Godot will automatically create a function in your player's script. This function will be called wherever the signal is emitted. It handles the signal. The signal, instead of having Godot create a function, you can also give the name of an existing function that you want to link the signal to. Okay, I'll pretend like I understood what had just happened for the sake of moving forward. On player body entered. Yeah, I guess that makes sense. So we're gonna copy this, I guess. And we're gonna get the weird indentation thing again. We'll find out soon. God. Very weird, but okay. Each time an enemy hits the player, the signal is going to be emitted. We need to disable the player's collision so that we don't trigger the hit signal more than once. Oh, okay, so when we hit, that's why we do call deferred, set disabled. Okay, because otherwise it's going to be hit. Okay, correct, makes sense. So this means I hit an enemy, I'm going to hide the player, I'm going to say, I hit something, and someone outside is going to manage what's going to happen next. And then I disable this, because otherwise the guy is just going to keep saying, I hit something, I hit something, I hit. Okay. Last piece for our player is to add a function we can call to reset the player when starting a new game. So we're going to add this function start. I actually want this to be at the beginning. It makes a bit more sense for me. Position equals pause, show, and then collision shape 2D disabled equals force. I wonder whether call deferred is like a performance thing, but yeah. Now it's time to make the enemies our player will have to dodge. Their behavior will not be very complex. Mobs will spawn randomly at the edges of the screen and move in a random direction in a straight line, then despawn when they go off screen. Makes sense. We will build this into a mob scene, which we can then instance to create any number of independent mobs in the game. Cool. So, scene, new scene, and we'll create the mob. The mob scene will use the following nodes. Okay, so new scene. Rigid body 2D. Boom. We're gonna, how do I want this to be a new thing. How do I do Scene, new scene. Okay. Rigid body 2D. Named mob. Animated sprite. Animated sprite. Then we need a collision shape 2D and a visibility notifier. Very fancy. Visibility notifier 2D. These shouldn't be children of each other. Does the order matter here? I guess it doesn't, but I'm going to be precise and follow it. Now mob. Okay. I forgot to do this. So here we are. Don't forget to set the children so they can't be yes. And the rigid body 2D properties set gravity scale to 0, so the mob will not fall downward. Okay, why didn't I have to do that before? Zero. Okay. In addition, under the physics body 2D section, click the mask property, physics body 2D. Where's that? Oh, that's because it inherits physics body. Okay. Click the mask property and uncheck the first box. What does that mean? This will ensure the mobs do not collide with each other. Okay. Now let's set up the animated sprite like you did for the player. This time we have 3 animations: fly, swim, and walk. Set the playing property and inspector to on and adjust the speed setting as shown below. We'll select one of these animations randomly so that the mobs will have some variety. Oh, maybe I had to change that for the other guy as well. Okay, but anyway, let's start doing that. Animated sprites. New sprite frames. We have swim. And then there is fly and walk. On fly, oh, 1, 2. It's gonna be 3, 4. Hey, why aren't you saving this? Okay, 3, 4, 4. Got that. Swimming 1, swimming 2, walking 1, walking 2. Why is this enormous? Okay. Fly should be yep. Now I need to be scaled down. Animated sprite scale is under transform. Scale 0.75. No, 0.75. Okay. Cool. As in the player scene, add a capsule shape 2D for the collision. To align the shape with the image, you need to set rotation degrees property to 90. Ooh, okay. Capsule shape. Do I then? I guess I do. Like a pro. Dope. Boom. Okay. Add a script to the mob and add the following member variables. BDB, boo boo, ba bam, bada bam, boom. When we spawn a mob, we'll pick a random value between min speed and max speed for how fast each mob will move. It would be boring if they were all moving at the same speed. We also have an array containing the names of the 3 animations, which we'll use to select a random one. Make sure you spelled these the same in the script and in the sprite frame resource. Makes sense. Now let's look at the rest of the script. In ready, we randomly choose one of these animation types. Nice. Animated sprite animation is one of those mob types. Randy. Okay. If you want your sequence to run under a different window, we're going to use randomize in our main scene, so we won't need it here. Randy. Okay. The last piece is to make the mobs delete themselves when they leave the screen. Connect the screen exited signal of the visibility node. Oh, dude, this is going to be screen exited. Oh, okay, I understand this kind of thing now. It's so when I'm connecting it, what it means. Okay. Where is it? Oh, was I supposed to call it visibility? Named visibility. That's my bad. Where are we? Here. So let me call this visibility again. Visibility. Does that automatically save my thing? I think it doesn't. Shit, maybe I should recreate it now. Oh, I haven't saved this yet. Save. So let me do this. Ability, no. Disconnect. And connect again. Now it's on visibility. Okay. Cue free. What does that mean? What does cue free mean? I didn't add this to notes too. I need to add this to the notes. I don't know what cue free means. Why aren't you explaining this to me? Connect the screen. What does it mean? Okay, maybe I can use the documentation thing. Nice. Queues a node for deletion at the end of the current frame. When deleted, all of its child nodes will be deleted as well. This method ensures it's safe to delete the node. Contrary to the object-free use. Okay. Is it... I wonder whether it's Godot that deletes it? Or it's something else? I don't know. But we'll see. We'll see soon. Now it's time to bring it all together. Create a new scene and add a node called main. Okay. It's getting exciting. We're kind of getting there. This is... Oh, I found a shortcut to create a new scene. Nice. Add a node. All I want is a simple node called main. Let me save this. Okay. Click the instance button and select your saved player. Nice. Nice, sweet. Okay. Now add the following nodes as children of main and name them as shown. Values are in seconds. So you know what? I should have done this at the beginning just to make my life a bit easier. No, you're not going to be able to read this very well. Okay, let me do it over here. Timer, named mob timer. So, timer, named mob timer. Then we need a score timer. This is not score timer. a start timer. And then we need a position 2D to indicate the player's position. Start position. Okay. Set the wait time property of each of the timer nodes as following. Mob timer 0.5. Score timer is 1. And this guy is 2. In addition, set the one-shot property of the start timer to on. And set the position of the start position node to 240, 450. Transform position 240, 450. Spawning mobs. The main node will be spawning new mobs and want them to appear at a random location on the edge of the screen. Add a path 2D node named mob path as a child of main. What was it? Path. Damn it! Path 2D. Another thing to add to the notes. I usually use Shift Command right left to select stuff. That doesn't work. It wants an Alt Shift right left. I'm not sure why. Anyway, Path 2D as a child of main. So this is my mob path. When you select Path 2D, you will see some new buttons at the top of the editor. I do see some new buttons at the top of the editor. Select the middle one, add point, and draw the path by clicking to add the points at the corners shown. To have the point snap to the grid, make sure snap to the grid is checked. Where is snap to the grid? I don't know, we'll see if it's enabled or not, and then I'll worry about that afterwards. I think snap to the grid is not enabled. What was I supposed to name this? Mob path. Kind of getting there. I almost forgot it was a live stream for a second. I was just thinking I was recording stuff. Hello, are you still there? Is this still entertaining? Was it entertaining at any point of the live stream? I wonder. I think I might have gotten to the point of I'm done. Like, okay, it's been an hour. It's been good, but I think I need to take a rest, take a break at least. I don't know, how much is there left in the tutorial? There's still some stuff left. So I think I might just take a pause here and continue in the next live stream, recording, whatever it is. It's super cool. I'm having fun with this. I'm going to be tempted to do this on my own, but I made a big mistake today, which was deciding to keep standing up instead of sitting down. And I don't have a chair with me, and my back is starting to hurt. And yeah, I think that's gonna wrap up the live stream for today. Very abruptly. I'm not sure whether you're expecting this, but you know, unexpected events in cinema always work. But anyway, just to bring back some energy, I hope you enjoyed this. I hope you found it somewhat entertaining, somewhat useful. If you did, as always, please leave a like. Let me know down below in the comments. Subscribe if you enjoy what I'm doing. There are other videos on my channel about, you know, end-to-end testing and other stuff, but I'm probably going to be doing more and more of this game development. It's really intriguing to me, but like I said, I need a chair. I made a mistake today. But yeah, I might be doing another live stream. I might not. I'm not sure. Did you enjoy the live stream format? Do you think it's better than me recording videos and editing stuff? If you do, let me know. because this is a lot easier for me. It's just, you know, start streaming. I don't have to worry about editing anymore. It's going to be on YouTube already. But maybe the edited videos are a bit easier to watch, or a bit easier to digest. They're like closed. There isn't any of me. There's not much of me doing, why isn't this working? How is this doing? But yeah, that's enough rambling for me. Thanks for following so far. I hope you enjoyed it. I hope you found it kind of useful, and I feel like I'm saying the same things over and over again. That's all from me. Thanks for following again, and I'll see you soon. Ciao.